Hi guys, remember that walk-in freezer video I did like 2 weeks ago-ish? Well, I'm back. They called this morning and said it's warm again, so we're gonna go check it out and see if we have a possible callback on something I missed or if we have a new issue. It's an older system, but like I said in the previous video, I didn't see a need to hook my gauges up and check the sealed system. Maybe I should have, I don't know, but we're gonna find out, all right? So stay tuned. Yeah, it's definitely noticeably warm in here. Doesn't appear to be a defrost issue. I got $100 saying we're gonna be low on charge or something silly. Pull that off. Or we're just not running it at all. That's also a possibility. I don't hear any telltale hissing noises from our TXV, so. The liquid line isn't warm at all. I'll bet you our condenser's not running. All right, let's go check it out. Well, my initial observation is there's nothing going on. If perhaps we were cycling on and off on low pressure, I should at least hear my condensing fan motor run, eh? Compressor's not even warm. Wouldn't it be hilarious if it turns out that somebody just shut the breaker off because they were like doing inventory or it's truck day or something and they were just getting chilly? Because today is Monday, which means yesterday was Sunday, right? Let's see, 3 plus 4, carry the 1, 7 minus 2, Tuesday, Wednesday, yeah, so yesterday was Sunday. And from my experience in the restaurant industry, they normally do inventory on Sundays. So this is going to be super hard to do with one hand. All right, hold on. Looks like we're calling for cooling, right? Let's check our incoming side of our contactor. Got all the right voltages, but our contactor isn't being energized. Let's check our contactor real quick. All right, I got no control voltage to my contactor. See, compressor contactor. One side is energized by the incoming load because it's a 208 contactor. The other side is apparently controlled by ASC, which is an anti-short cycle device, which is gone. I don't know if it's ever been there, but that's gone. Dual pressure control, so I suspect our dual pressure control. See, now if it was, unless I just have no voltage going to it, but if it were open, I should have, I should be able to have, I should have potential difference is what I'm trying to say. I should have voltage. I don't have anything to ground. And this one is going directly to my compressor. All right, well, let's take the compressor top off, because also, well, no, I think I need to retract my earlier statement. Our condensing fan motor is well then, doesn't really show my condensing fan motor, but retract my earlier statement of if we were short cycling on low pressure or something like that, my condensing fan motor would run. I don't know if that's necessarily the case. So some of the other ones, that is the case. This one might not necessarily be the case. But I mean, looking at all this oil, all this residual oil all over everything, like I said before, wouldn't surprise me if we had a leak. But then again, last time I was here, my sight glass was full. So anyway, let's pull that compressor cover, see what we got going on over there. Well, you guys didn't tell me that that is actually my fan cycling control right there, cycling my condensing fan motor. All I did was hit my little reset button and it started right up. So we either have a pressure problem or we have a fan cycling problem. Now that we have a compressor running, it's under load, it should be doing something. But we're reading 208 and it should be closed. I should have 0 volts right there, because we should have enough pressure in the system that it's high enough, or enough high pressure in the system, I guess. The head pressure should be high enough. Let's say that, let's go with that. The head pressure should be high enough that it should close this switch and kick on my condensing fan motor. Unless that switch is bad. So, I'll run downstairs, grab my gauges, and we'll hook up to this thing and see where we're at. All right, here we go. Got my gauges hooked up. Really nothing to see, nothing to, really to explain. I assume we'll just see our head pressure climb and climb and climb, and then it'll eventually cut out on. Looks like about 450 psi is what it cuts out at. Obviously our head pressure is high enough right now. It should close, but it's not. Feel that needle just vibrating. And real quick, I just want to make sure that my switch isn't closed. All right. Still got voltage across there. The circuit is open because there's a potential difference. I don't want to create any undue stress on this old compressor right now. I'm going to bypass that, and I'm just not even going to leave it in the circuit anymore. We're going to completely get rid of that. Not completely. I'm just going to wire nut this bitch. Some bitch. I'm going to put that in my notes too, that word, S-U-M-B-I-T-C-H, some bitch. Anyway, I'm going to bypass that. It's supposed to be like 70 degrees out today where I'm at in Michigan. I believe summertime has finally arrived, so I don't really need a fan cycling control as much as I used to, maybe during the fall. So there's no headmaster on this thing, but I am going to quote to just have this system simply replaced because it's getting about that time. I don't see them really wanting to put a whole lot of money into this anymore, but yeah, we'll see. We'll see. They're doing kind of funky things with remodels and various things. You know, inflation is causing all sorts of different variables for the restaurant industry, I suppose. But yeah, let's bypass that real quick, put a wire knot on it, and then we'll fire it back up and see what happens. Real quick, let me address a couple things. Yes, I do like to put tape on my wire nuts, only because I'm paranoid about them slowly vibrating and coming loose. Secondly, also moisture intrusion. Could it happen? Maybe. The odds of it happening, slim to none. But it makes me feel better. It makes me feel better inside. Secondly, you might be wondering why I'm not in the Wagyu game. Why I'm not using Wagyu connectors, which, if you're not familiar with those, it's like a little plastic block. It's got two little flip-up levers. You just jam the wires in the side, and then you push the lever down, and holds them in place. That's like a fancy man's wire nut, right? Well, I have 600 trillion wire nuts in my truck right now, so I'm not just going to jump on the Wagyu train yet. I mean, they look nice, they look fancy. It's going to do the same thing as this wire nut's going to do, so why am I going to abandon all the wire nuts, which have served me well over the years, for some Wagyu connections? Secondly, you might be wondering why we even need a fan cycle control to begin with, right? Which, by the way, if you know what a Wagyu connection is, you probably already know why we need a fan cycling control. So you can fast forward through this part of the video. But essentially, this system doesn't have a headmaster, right? And we want to maintain a certain quality, a certain pressure of liquid going down into our thermal expansion valve in order to feed it properly. And these older systems, I don't know what the exact pressure drop is, but they require a much higher pressure drop than some of the newer systems, right? And a condensing fan motor cycling switch is, I don't know, what I like to call like a poor man's headmaster control. It's set at a certain pressure that it will obviously turn on when it gets too high, so we don't trip off on high pressure, which is what's going on. But it'll go off in order to let that head pressure build up. Like say in the fall and the winter time, we want a higher head pressure, right? And it's going to be harder to get that higher head pressure with the condensing fan motor running when it's 0 degrees outside, because the condenser is so easily cooled. The high pressure refrigerant, I guess, is so easily condensed when it's 0 degrees out and you have cool air blowing across it that we need to shut that condensing fan motor off just so we can try to build up enough pressure. And even then, there's no guarantee that just because we shut the condensing fan motor off, we're going to build up the amount of pressure needed to properly feed that thermal expansion valve downstairs. So in the summertime, which is basically summertime right now, it's the a couple days after Easter here, or literally, I take that back, it's literally the day after Easter. It's supposed to be 70 degrees out today. I don't see a need to cycle this fan on and off. Now granted, it still gets kind of cooler at night, so the system won't operate as efficiently as it should, right? Meaning that tonight, when our temperature drops down to say 50-ish, mid-50s maybe, the liquid going into that thermal expansion valve downstairs isn't going to be as high of a pressure as possibly it needs. It'll still feed the thermal expansion valve, it just won't be as efficient. We're going to get a little bit slightly less of a pressure drop across the expansion valve. I mean, is it really going to make a big difference on this system? No, because I mean, there's so many other inefficiencies in this system, so they probably really won't even notice. But the cooling capacity will be slightly lowered, I guess, at night. But all that just to sort of explain what this is for. If that doesn't help, there's a bajillion documents and other videos that properly explain this. Actually, the best explanation I've found is from Dick Wer's book, Commercial Refrigeration for Air Conditioning Technicians. He covers this very well with pictures and descriptions and all sorts of great terminology. But yeah, essentially we just want to make sure we have enough pressure building up to properly feed our thermal expansion valve. And we can't properly feed a thermal expansion valve in the middle of winter with a condensing fan motor running and our liquid being subcooled, our liquid being a much lower pressure than we need it to be. So yeah, that's it in a nutshell. So we got this bypassed. walking 404 in this guy, so that's about as high as I want to see it. I don't want to see it any higher than that. If you notice, we are bubbling, but last time I was here, I was bubbling as well for a short period of time. So we'll keep an eye on that. It literally just started, so that could be part of the problem. But my head pressure is pretty close to right where I want it to be. I don't want to go just frivolously. Is that a word? Frivolously? I don't want to just add refrigerant just because my sight glass tells me I need to, right? Also, by the way, if you wonder why my needle is just vibrating so terribly, it's because I'm so close to the compressor head. I'm literally just like an inch away from the valve on the compressor, so my needle's going to vibrate. They do make gauges that are liquid filled, where this isn't really an issue. I did try to connect to that earlier, that fitting right there, but the stem on the valve is leaking so badly I couldn't open it without just dumping refrigerant out, which, I don't know, I lost maybe a couple ounces of refrigerant just trying to maybe get it to seal. I backed it out all the way, thought maybe that would help, but it just kept dumping refrigerant, which could be why we have a bubbling sight glass now, but just don't tell the EPA. So anyway, with our hyper vibrating needle, it looks like we're at about a 90, 95 degree condensing temperature. Of course, obviously it's hard to see because we're vibrating so badly. Could I go get out my digital or my eye manifolds? Yeah, but am I going to? Probably not, because this system is just, I don't know. I look at a system, and a system like this where it has literally so many issues going on with it, just run down and beat up. I'm like, yeah, these gauges are fine enough. There's only a certain amount of fine tuning you can do on a system like this, in my opinion, in my humble opinion. You know, it is what it is. But all that just to say, my eye manifold probably wouldn't have such terrible fluctuations to it, which we can just go like this and sort of close it down just a little bit, right like that, and see. You just close the valve ever so slightly. Kind of levels it out a bit. I don't know how well you guys can see that, but we have just a little tiny bubble in our sight glass now, and it's slowly going away. As our load and system, I guess, equalizes. Hopefully you guys can see that. Slowly going away, going away, going away, and it's going to be gone in a second. There we go. Don't pay attention to that. It don't work. Not sure why it doesn't work. Our sensing bulb is intact, but looks like we're just a hair below 20 degrees. I think we're up to 30, 35 degrees when I first got here. Now, I'm not using these as a scientific tool of measurement. I had my own probe in here a little bit ago, but I took it out. So just for the sake of this video, I'm going to reference this thermometer. But yeah, my temperature probe is actually about 17, but I had it a little bit closer to the return on the back side of that, but I was closer to 17. But like I said, I already went out and put it in my truck, and I don't want to get it back out again. So with that's it for now. It's running. I'm going to tell the manager to keep an eye on it, and hopefully the next time I come here will be to swap this guy out. All right. Thanks for watching, guys.